Now we are going to start the second topic of particulate nature of matter. In the previous topic, solid, liquid and gas, we have studied the universe is made up of matter, and matter contains the three fundamental states, solid, liquid and gases, and we studied the fundamental properties, right? Shape, volume and temperature dependence. So now we will study the second topic of particulate nature of matter, that is kinetic theory of matter. Kinetic theory of matter you will also see later, maybe in your higher studies, or maybe if you Google it, or if you want to find information about this topic, you will also get kinetic theory of gases. That is a different theory. That is also for state of matter, one of the state of matter, but it is only dedicated to gases. So that is kinetic theory of matter. But here we are studying kinetic theory of matter. It is applicable to all state of matter. Right? So kinetic theory of matter. First of all, let's start and go to one by one all the words. Let's clear it out. What do we understand by the word kinetic? Maybe you all are having kinetics in your homes, right? Kinetic means which will take you from one place to another. It is one of the automobile, right? If we speak in terms of vehicles, like we have cars, we have kinetics. Kinetics means scooter. So that is to take you from one place to another. It means it is mobile, moving. That's why we call it kinetic, right? So when it comes to particles, right, microscopic particles, there also if we say word kinetic, it means they can move, right? Say, if I am speaking about myself, suppose I am standing here, it means I am having potential energy. Slightly physics, I am having potential energy. If I move, my potential energy is converted into kinetic energy, because we know energy can neither be created nor be destroyed. It can only be transferred or converted from one form to another, right? Similarly, suppose I have a stone in my hand. Now the stone is having potential energy. If I throw the stone, the potential energy is converted to kinetic energy. That's why the stone is traveling from my hand and going to the ground. After reaching to the ground, now again the kinetic energy is converted to potential, because it is at rest, right? So if we say the word kinetic, then what comes to our mind? What do we study in this topic, or what are we going to get in this topic, right? Movement of matter. And what is matter? Solid, liquid, gas, right? So kinetic theory of matter. So it gives us explanation. So it gives us explanation about the movement of matter. But when we explain something, suppose I discover something, right, and I want it to explain it to you. If I say this is my invention and it has this properties A, B, C, X, Y, Z and all, will you believe me? No. I have to give you some evidences, right? So when we discover something, when we get some idea in science, we have to predict something. That this is my prediction, that A forms B, A color is red, A gets white when it is exposure to light. So it means all these properties, but I have to give you scientific explanation with respect to that. So kinetic theory of matter gives us information about movement of particles and the evidence it takes based on the idea that matter is made up of particles, right? And this explanation is based on evidence that matter is made up of particles. Okay. So what is kinetic theory telling us? Kinetic theory is telling us the behavior of matter. That particle of matter, they are moving, right? They are moving all the time. So it means kinetic theory gives us the behavior of matter, and that behavior is in consistence with the matter is made up of particles, and this evidence is based on a physical property. The physical property is that matter or the particles of matter, they are in continuous motion, right? So this is the basic idea of kinetic theory of matter, right? That how it behaves. Evidence is that they are made up of particles, right? Matter is not moving. The particles present in matter, they are moving, right? And if they are moving, the physical property that is being taken into consideration is movement of matter, right? So let's go one by one to all the postulates of kinetic theory of matter. So for your 9th and 10th IGCSE, we just have the 3 major points for kinetic theory of matter. Number 1 is the matter is made up of particles. The matter is made up of particles. These particles can be atoms, ions, or molecules. The particles can be atoms, ions, or molecules. Now different type of substances have different type of particles. Maybe one substance contain only atom, say I speak about iron, it is containing say iron atom. Maybe some contain ions like NaCl, it will contain Na plus Cl negative, it is containing ions. Some particles or some matter, some substances, they contain molecules, like if we say oxygen gas, it is containing O2, O2, O2. O2 is what? A molecule, a group of atom, a diatomic molecule. So it means maybe some substances, they contain atoms, some contains ions, and some contain molecules. One more remarkable point about particles, that they are microscopic. You cannot see these particles with your naked eye, right? If you want to see them, you need to use some technique, right? Next point. As I said, the idea, the physical property that they are using here in kinetic theory, it is based upon movement of matter, right? So if I say movement, what do you need if you want to move? Suppose I have to cover 1 kilometer in just 10 minutes. I have to reach somewhere in 10 minutes. Then what do I need? Energy, right? If I have a lot of energy, I can run and can cover 1 kilometer in 10 minutes. If I have less energy, I can't do. Less energy, or if I'm very fat, I can't run so fast. A very thin, sweet girl, she can run very fast if she is full of energy. So it means I'm considering 2 points. One is energy, second is your weight. If you are really very heavy, you can't run so fast. If I expect a 90 kg woman to run 1 kilometer distance in just 15 minutes, that's not so justified. She can't do it because she cannot carry her weight, and she can run so faster to cover 10 kilometers or say 1 kilometer in just 15 minutes. Am I clear? So now we are talking about energy. So let's take one by one. First is energy. So if I say energy, it means how do you get energy? How particles get energy? They get heated up. So if you increase temperature, if you decrease temperature, the movement of particles decreases, right? So higher the temperature, faster is the movement, of particles, and vice versa, right? Next is, if you have heavier atoms, they move slowly, like a heavier woman, a heavy child, say 80 kg, just 10 years old, bulky, he will walk slowly. A thin, fit one, he will run fast. So a heavier atom will move slowly, and the lighter particles, lighter atoms, they move faster. So heavier atoms move slowly and lighter atoms move faster. This is our kinetic theory of matter. So here the main idea is that how the particle behaves or how the matter behaves. The behavior of matter can be explained if we know the internal core structure, that is the particle nature. Matter is made up of particles and we are considering the physical property, movement, and based on the movement we are explaining the movement based on the energy as well as on the weight or size of the particles. And the fundamental point is matter is made up of particles, different substances, different type of particles, and maybe the size of particles also vary. Maybe say if we speak about hydrogen, if a substance is made up of hydrogen, hydrogen is small. One substance is made up of iron, iron is big. So depending upon the substance that you are using, maybe the size of the particles, size of atoms, ions, molecules, it will vary. Right? So let's move further for kinetic theory of matter. If you want to note, please have a note of this information. Right? Again, any questions, you can email it to me or you can also write a comment. Then based on that, I will get back to you soon with the answers of all your queries, and if you want any particular topic to be discussed, that also you can write in a comment that I will discuss with you in the next forthcoming videos. Otherwise, I'll share you the link that you can get this topic in this particular video. So the next topic is, not the next topic exactly, the next information in kinetic theory of matter is, it is a scientific tool, a scientific evidence, right? When we speak about behavior, the scientific evidence in terms, because when we speak movement, let's go into the internal core of matter, right? Internal core of atom. Then first of all, we have to see the arrangement, right? Arrangement of particles, how they are arranged. Based on that, we can comment that if this is the arrangement, then what is the consequence? Right? So based on the arrangement of particles, we can define many properties. As I said you in my last video, that if we study solid, liquid, gas, the basic information is how they look like. How can you differentiate it's solid, liquid or gas, or why it's solid, liquid or gas? Now if we go to more internal structures, then we will study that in kinetic theory of matter, we will get some scientific evidences where we can explain in more detail that if this is the arrangement, this is the property exhibited. So let's see further. So if this is the solid, the particles are close to each other. This is the arrangement. Sometime in IGCSE you will get question that write differences in solid, liquid and gas. Maybe the language is different. So we have to be very specific, because in IG exams you will get scores based on the keywords. Maybe your explanation is correct, but you are not using the keyword, then you will not get scored. So they will not go for your broad explanation. They want to see those keywords. So if in solid they are asking for arrangement, there is one word which will describe all your explanation. That is, they have a regular arrangement. Regular. This word is mandatory when we speak about arrangement of solids, right? And the arrangement of particles in solids. The particle can be atom, molecule or ion, right? So the arrangement is regular, right? This is the keyword if they ask the question related to a solid, right? So this arrangement is regular. When we say the particles are very close, if you want to keep two people close, they should be bonded to each other. They must have some bonding, some attachment. If they are fighting all the time, can you keep them in one room? No? Suppose you keep two boys in one room, they continuously fight with each other, they will break each other's head, they will not stay in one room. If they have a close bonding, then they will stay. What is bonding? Is there any stick? Suppose I say this is one atom, this is second atom, and the stick is joining them. No. Bonding is a force of attraction. So here also, if particles are staying close to each other, it means there is a strong force of attraction. Now what is this force of attraction? There chapter bonding and structure, right? So for now you just understand in other ways, if we have to keep two people close, similarly if we have to keep two particles close, there must be force of attraction. Force of attraction means a kind of bonding, right? So in there is a strong force of attraction between the particles. So, at a particular temperature, the particles cannot leave their place. They can slightly vibrate at their mean position. So if this is the particle, it can slightly go to left, slightly go to right, slightly go to left, slightly go to right. So if this is my mean position, like a pendulum of a clock, slightly it can go to left, slightly it can go to right. This is the just. I'm at the same position, slightly just oscillating or vibrating at my main position. So in solids, particles vibrate at their mean positions. Particles vibrate at their mean positions. So based on this regular arrangement, strong force of attraction and localized at their mean position, solids have a particular shape. Sometimes they ask question in IGCSE exam, why solids have a specific shape? So solids have a specific shape because of a regular arrangement and particles are closely attracted to each other, right? And now add to your knowledge for your MCQ exams, sometimes they ask how can you determine the structure of a solid. So we have a technique for it that's called X-ray crystallography. So X-ray crystallography is a technique which is used to determine the structure. As in the previous video, I drew NaCl structure. So how did we come to know it is like that? The arrangement is like that. So X-rays are passed through solid, then you can see the image of internal structure on the screen. So it is like that. As X-ray pass into the body, then doctor can diagnose what is going on inside the body, right? Especially bones. Similarly, X-ray crystallography is a technique which is used to determine the internal structure of a solid, right? And as the particles are closely packed, there's a lot of attraction between them, so they have low energy. The energy here is very, very low, right? That's why solids react less. They will react, but there are many conditions for it, but they have less energy, or you can say that they have lowest energy as compared to other state of matter. They have low energy. So because if they have energy, they will not stick to one place. The particles will move. The particles are not moving, localized at one place, slightly vibrating, it means they have low energy, right? So that information was given by theory, explained the behavior of particle of matter in different points for matter, as well as the other properties of the movement and in context with the arrangement. So this is the arrangement. Movement is just vibration. So I have seen few questions in IGCSE exams where they ask about the arrangement, why solid have a specific shape because of that arrangement, as well as what type of movement is being exhibited. It is just vibration and the energy very low. So now let's go to the liquids. So now we are classifying properties of solid, liquid and gas based on the scientific explanation given by kinetic theory of matter. So now next is liquid. Liquids. Liquids means if I say this is my liquid, this is my container, half filled with liquid. So particles are here, 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 here. So is there any arrangement that you can see here? No, no arrangement, right? Particles are slightly away, not very far, slightly away as compared to solids. There is a space between particles. How can we prove that there is a space between particles in liquid? Okay, do a small activity that you can try even at your home. Take a pinch of solid, say NaCl. Take a transparent glass container, fill it half with water and make a mark with a red pen, blue pen, anything, any color. Make a mark that water is filled up to here. Suppose I have this glass container. Suppose I filled it with water and I mark it here. Then add 2 spoons of sugar or salt to it, dissolve it. Right? Okay. Again check the level of water. Is it same, going high or low? It will remain exactly same. Why? Because the solid particles, if they are coming into the medium, they are occupying the space between liquid particles. So the level of volume is, the level of liquid is not rising, right? So it means particles, this activity proves that there is a space between particles, right, in liquid. Random arrangement. So as we saw in case of solids, the arrangement was regular. It means the particles were occupying a certain position. That cannot happen in liquids. If this is the volume, if this is the margin of the liquid, the molecules or particles can move anywhere in this prescribed volume, right? So it means they have a random arrangement. So next we were studying about attraction. So particles in liquids have less force of attraction as compared to solids. That's why they are slightly apart. In case of solids, the particles were very, very close. So it means they were strongly bonded. So they were very close. So in liquids, there is a space. As we have seen, we can prove it by doing some small activity. If we dissolve a small pinch of salt in 1 glass of water, the level of water will not rise or fall. It means the particles of salt will enter into the space between 2 liquid molecules. So it means if there is a space between the particles, there is less force of attraction as compared to solids, right? Arrangement is random. This is a key word. This is very, very important. So if it comes to arrangement, if we speak about solid, it is regular. If we speak about liquid, it is random, and the force of attraction is less as compared to solids, right? And the third point is, if there is space between the particles, and there are many particles, it's not like 10, 15, 20, there are millions of particles, even if we take 10 ml of liquid. So they continue to collide with each other, right? So it can collide with this because their position is not fixed. If position is not fixed, they will move in all directions, randomly moving in all directions. And when anyone, suppose there are 100 people in a room and they are randomly moving in all directions, they will collide with each other, hit each other. Similarly, it will happen here. These particles randomly moving in all directions, they will continue to collide with each other. So the third point that we can take up here is the particles in liquids will collide with each other. Continuously. So we have seen arrangement, we have seen attraction. In solids, we have seen particles continue to vibrate at their mean position, but here the particles will move in all directions randomly, and there is less force of attraction. That's why it is liquid, and that's why there is a space between the particles. And the particles in liquid will continue to collide, and whenever there is a collision, always there is a release of energy. So liquids have higher energy as compared to solids. So the points of focus according to kinetic theory of matter in terms of behavior or in terms of movement of particles. In liquids, the arrangement is random. They are having less force of attraction as compared to solids. The particles in liquids, they continue to collide because they are randomly moving in all directions. So this point is the consequence of this point. And then finally, as they are colliding, it means they must be having higher energy as compared to solids, right? And the properties based on it and the behavior based on it, we will see in the next video. So now the last state of matter, according to IGCSE syllabus, gases. So if we have a broad understanding of all the properties, we can explain anything that comes for solid, liquid and gases with appropriate keywords that will fulfill the requirement of every question of this chapter, right? So the major basic understanding is required. So in the next video we will study about the application. If we have this property, then what is the further application of it, right? So the next properties are gases. So gases, again, if it comes to arrangement, how we can say it? Arrangement is again random, right? So we again use the same word. They have a random arrangement. Because if we speak about liquid, as we have seen for liquid, if we fill liquid till here, the molecules will stay in that space, right? It will not go away from it unless you give some heat. That is a different part. But if you have filled the liquid till here, the particles of liquid will move, but only in this space. But suppose you have sprayed some gas or you have filled some gas in a container, but it will occupy full space. You cannot limit a gas up to a particular volume. Whatever is the space available in a container, in a room, in a hall, in a country or a state, it will occupy the full space. So we cannot limit a gas to a definite volume. So if we speak about gas, it will enclose the full space available in the container, right? So they have a random arrangement. Next point is, there is least force of attraction. There is least force of attraction between the particles. And the evidence for it is that, as I have given in the previous case also, suppose I have sprayed one perfume bottle in the corner of a room, we can feel the fragrance everywhere. Suppose we are cooking something in the kitchen, we can feel the fragrance of food everywhere in the house, because the particles are moving as much space as they are getting to move. So it means we cannot enclose the gas particles in a definite volume. They will continue to move. It means they have least force of attraction. In solid, the particles were very, very close. It means there is strongest force of attraction. Distance between the particle increases, it means the force of attraction between the particles decreases. So in liquid there was space between the particles, it means they can move but only up to a finite distance. If we speak about gas, the particles can move to an infinite distance. If you release them into the air, it can travel to any distance. It means the force of attraction between them is negligible or very, very less. Why I am using the word less? Because still there is force of attraction. That's why we can liquefy them. Otherwise gases can never be liquefied. But we know there is a property where we can even solidify gases. So there is a force of attraction, but it is least. So in gases also, particles collide with each other. Now see, suppose there are two particles, this is the distance. If they come and collide, the distance between them is less, so less energy. Suppose one particle is here, the other particle is there, and if they collide, more energy. Okay, so particles collide with each other. Particles collide with each other continuously and moving in all directions in the available space. So in gases we have seen the arrangement is random. The random word is very important. It is the key word that must have to specify when we speak about arrangement. Second is the force of attraction is the least. Maybe in some of the books you will find negligible or there is no force of attraction. Why I have word used least? Because we have the probability of converting gases into liquid, which is only possible if there is some force of attraction. Otherwise you can never liquefy. Next is the particles collide with each other with greater energy because there is huge space between them, and they are already moving in all directions with different velocities, right? They have highest energy, or they have max energy. So the simplest example, the smallest example for max energy is, suppose the boiled water spill over your hand, it will burn your hand, right? On the other hand, do one thing, sometimes if the fumes are coming out from water and if you bring your hand closer to it, then it will burn you more severe because in fumes there is gas, water vapors, so it has more energy. So you can also try, but don't try, it's harmful. So when we bring our hand close to the fumes, close to the steam, it will cause more severe burns as compared to the boiled water. So with this, kinetic theory of matter is done. In this theory we have studied about the behavior of particles of matter, on what basis this behavior is being explained, different postulates, and the scientific aptitude for arrangement, and how solid, liquid and gases the particles are arranged, and what is the consequence of that arrangement. So for the next topic, please watch the next video. Till then, bye bye, have a good time, see you.